two concentric thin conducting shells. So what is the expression to find out the capacitance? So here, what is the method? So here I'll connect already or come across. Just let me revise that. There's the applied voltage, say V. Then the positive charge will flow here. This charge will go and deposit. It will induce charge minus Q, and plus Q from here will flow like this. So whenever the spherical shell comes, no, the cell has to be brought so that it will be very easy for you to understand. Then what is the capacitance? So we'll call this is A, this is B. So potential difference VA is equal to KQ by A minus KQ by B, and potential difference, this is KQ by B minus KQ by. So what is VAB is equal to KQ by A minus KQ by B. And I'll replace this with an equivalent capacitance. The charge on inner surface of positive plate should be the charge of capacitor. This should be the charge of capacitor. No? So therefore, so what is the VAB should be equal to Q by C, KQ by 1 by A minus 1 by B. This should be equal to Q by C. Solving this, this will be K. Just I'm making you to recollect. So what is the capacitance will be? AB by K B minus A, or C equal to 4 pi epsilon naught AB by B minus A. Now, if I fill up, this is, what is here? Here I'll assume that a free space. Here also there's a free space. Now, if I fill up a dielectric medium between them, then what will happen to the capacitance? That's what we are supposed to find out here. So if I fill up a dielectric slab, or then slab, dielectric medium, let me call, because no longer the rectangular plates will not be there. So then what conditions, what will happen to capacitance if I fill up a dielectric medium between the plates? This will be the second situation. Now we'll go for, this is the medium between them, I'll fill up with a dielectric medium. In general, epsilon r, usually we give symbol K, that one. Capacitance, will it increase or decrease in case of spherical capacitor? Let me call K, that one. This is again A, B. Again, the method is same. We are going to connect a cell between inner and outer. So a plus Q charge, here Q minus Q, and from here the Q charge will flow out. What is the capacitance of this? So we'll just take help of the electric. So potential will become, this is epsilon r, no? This K and that K. Epsilon r, I'll write it. No, what is the thing? So here how the electric field will be like this. Then how to get the potential difference? dV is equal to E into dr, that one. So what is the value of electric field? should be equal to Q by 4 pi epsilon r square dr.
Sir, minus 0 here.
I'm bringing that side. Okay, this is the basic thing. So I want potential difference. So VA, VB. So where the field will extend from A to B inside this one. So this will be A to B, you write it. So this will become VA minus VB Q 4 pi epsilon r will come outside, integral of minus 1 by r A to B. So everything only that epsilon r additional it will come, no? So therefore this VA by Q, in place of that it will be B minus A by 4 pi epsilon r AB. See, like already last week the advance you got the questions. It was really asked very fundamental questions on spherical capacitor. Then going for a higher level problem, just basic things first you analyze it. Basic things you have to analyze. So now VA by Q, so this should be equal to 1 by C. Okay, now all together. So what will happen to capacitance? 4 pi epsilon r AB by B minus A. So what will happen to here also capacitance will increase by epsilon r times. It will increase by here epsilon r times here. So when you fill up a dielectric medium between the region between the shells, then it will increase by epsilon r times. Now, same thing, this concept you can extend for cylindrical capacitor also, which what we use widely in the applications. Then parallel plate or even spherical one, no? The cylindrical capacitors are more widely used here. And now after this,